Welcome to Daily Papers, the podcast where we break down the latest research and what it means for you.
Today, we're tackling a really fundamental question in the world of artificial intelligence. How do we know if an AI is actually doing a good job?
That seems simple enough, right? If you ask it for the capital of France and it says Paris, that's a good job.
Exactly. For questions with one right answer, it's easy. But what about more open-ended, creative tasks? Like asking an AI to write a poem or come up with a business plan, or even just give helpful advice. Quality becomes subjective. It's nuanced.
So how do the big AI labs evaluate their models? Do they have thousands of people just sitting around reading AI-generated poetry all day?
Sometimes, yes, but that's incredibly slow and expensive. So increasingly, they're using other AIs to do the judging. They call them large language model judges, basically one large language model that grades the work of another.
An AI to judge an AI. That sounds a little like the fox guarding the henhouse. Can they be trusted to be good judges?
That's the core of the problem this paper addresses. The authors from Meta Superintelligence Labs point out that LLM judges can be, well, a bit brittle. They can be inconsistent, biased, and it's often hard to understand why they made a certain decision.
So to make the AI judges more reliable, researchers give them a rubric, just like a teacher uses a checklist to grade an essay, 1 point for grammar, 1 for structure, 1 for creativity, and so on.
Precisely. But that just pushes the problem back one step. What if the rubric itself is bad? The paper shows that a poorly designed rubric can actually make an AI judge worse than having no rubric at all. Their accuracy can plummet.
What makes a rubric bad?
They often lack coverage, meaning they miss important aspects of a good answer, or they're redundant with several criteria that basically measure the same thing, or they're just too vague with criteria like the response is helpful. What does that even mean in practice?
Okay, so the challenge is creating a really good, detailed, and comprehensive rubric. And that's what this paper, Rethinking Rubric Generation for Improving LLM Judge and Reward Modeling, is all about. They've developed a new framework to do just that, and they call it Recursive Rubric Decomposition, or RRD.
It's a mouthful, but the idea behind it is incredibly clever and surprisingly intuitive. Let's break it down. Rubric decomposition just means breaking big criteria down into smaller, more specific ones.
And recursive means the process repeats itself over and over, getting more and more detailed.
Exactly. The paper uses a great analogy. Think of a doctor diagnosing a patient. The patient comes in with a vague complaint, like just feeling unwell. A bad doctor might just make a wild guess.
But a good doctor starts a process. They might start with a broad hypothesis like inflammation, but that's not a final diagnosis. It's too general.
Right. So they order more specific tests to decompose that broad idea. Is it autoimmune? Is it infectious? They keep breaking the problem down into finer and finer pieces until they can pinpoint the exact cause. That's what RRD does with rubrics.
So it might start with a vague rubric like, the answer is high quality. If it sees that this rubric applies to lots of different AI-generated answers, it knows the rubric is too broad and not very useful for telling them apart.
So it recursively breaks it down. What makes it high quality in this context? Is it factually correct? Is it well written? Does it directly answer the user's question? And then it might break down well written even further. Does it have good grammar? Is the tone appropriate? Does it use clear language?
And just like a doctor, the system also knows how to throw out bad tests. The RRD framework has a filtering stage. It automatically removes rubrics that are redundant or that seem to be misaligned. For example, if a rubric consistently prefers an answer from a weaker AI model over a stronger one, it's probably a bad criterion.
The final piece of the puzzle is weighting. A doctor knows two different symptoms might be highly correlated because they have the same underlying cause. They don't want to double count that evidence. Similarly, RRD analyzes the final set of rubrics, identifies which ones are related, and adjusts their importance so that one single aspect of quality doesn't dominate the entire evaluation.
Let's make this concrete. The paper gives an example where the prompt was to write a short sales email. An initial set of rubrics might have included things like targets e-commerce owners and includes a call to action. Pretty basic stuff.
But after the RRD process, that initial set of 7 rubrics was expanded into a much more detailed list of 30. The final rubrics were incredibly specific, like mentions that faster loading times lead to higher sales, offers a specific service aimed at optimizing website speed, and even uses an analogy or relatable scenario to illustrate the impact.
That's a much more robust and useful report card. So the big question is, did it actually work?
It worked incredibly well. When they used these RRD-generated rubrics, the accuracy of LLM judges like GPT-4 shot up. On one benchmark, the agreement with human judgment improved by a massive 17.7 percentage points. The AI judges became far more reliable.
But that's not even the most exciting part of the paper. They didn't just use these better rubrics for grading, they used them for teaching.
This is where it gets really interesting. They used a technique called reinforcement fine-tuning. In simple terms, they had an AI practice generating answers. After each attempt, the RRD-powered judge would give it a detailed score based on that super specific rubric. The AI then uses that feedback to learn and improve.
It's like giving a student a detailed breakdown of their essay grade instead of just a letter grade. They know exactly what to work on for next time.
And because the rubrics were so much better, the reward signal, as they call it, was much stronger and more stable. The AIs being trained learned much faster, and their performance improved dramatically. The paper reports boosting the reward by up to 160% compared to older methods.
So what does that mean for the AI models we actually use?
It means they get better at what we want them to do. The models trained this way showed robust improvements across the board. They were better at following instructions, better at complex reasoning, and their performance even transferred to high-stakes specialized domains like providing helpful responses in a clinical medical dialogue.
So this is really a story about how getting better at defining what good looks like in a very granular and structured way is a key step to building better AI. It's not just about building bigger models, but about building smarter ways to guide them.
Exactly. By moving from a simple thumbs up or thumbs down to a detailed, statistically grounded report card, we can create more reliable, interpretable, and ultimately more helpful AI.
A fascinating look at the machinery behind AI alignment. That's all the time we have for today.
Join us next time on Daily Papers as we dive into another piece of research that's shaping our world.